So hi to everyone. My name is Teja Trivikram. I am from EEE department. Uh, Today I am going to explain about Thevenin's theorem, Norton's theorem, superposition theorem, maximum power transfer theorem, reciprocity theorem, and compensation theorem. So coming to our subject name, our subject name is Electrical Circuit Analysis 1. So the code of the subject is 23EEE101. So this is the info about subject and the topics. Coming into the topic, firstly we see about the introduction to circuit analysis theorems. Circuit analysis theorems are fundamental tools used to simplify and solve complex electrical circuits. These powerful theories provide a structured approach to understanding the behavior of interconnected components and how they interact with each other. So this is the introduction to the circuit analysis theorems. So here coming to Thevenin's theorem, the definition of Thevenin's theorem is Thevenin's theorem states that any two-terminal network can be replaced by an equivalent circuit consisting of a voltage source and a series resistance. So now we see about the applications. This theorem is widely used in circuit analysis. It is to simplify the complex networks and determine the maximum power that can be delivered to a load. Benefits of the Thevenin's theorem is it allows for a easier calculation of voltages, currents, and power in a circuit, making it a valuable tool for both analysis and design. So this is all about the Thevenin's theorem for definition and applications and benefits of Thevenin's theorem. So here the Norton theorem's definition is Norton's theorem states that any two-terminal network can be replaced by an equivalent circuit consisting of a current source and a parallel resistance. So the relation to the Thevenin's theorem is Norton's theorem is closely related to Thevenin's theorem, and the two are often used interchangeably to simplify circuit analysis. So applications for Norton's theorem is Norton's theorem is particularly useful in analyzing the behavior of electronic devices and circuits such as transistors and op-amps. Equivalence of Norton's theorem. Thevenin's and Norton theorems are mathematically equivalent, and the choice between the two depends on the specific circuit and the desired analysis approach. So this is all about the Norton's theorem. So just now we have seen about the Norton's theorem and Thevenin's theorem. Now we are going to the superposition theorem. The principle of superposition theorem is the superposition theorem states that the response of a linear circuit to multiply sources can be found by considering the individual contributes of each source and adding them together. Simplification of superposition theorem is this theorem allows for the analysis of complex circuits by breaking them down into simpler, independent circuits which can be combined to find the all-over solution. So applications for superposition theorem is particularly useful in the analysis of circuits with multiple voltage or current sources, as well as in the design of amplifiers and filters. So coming to maximum power transfer theorem, the principle of this theorem is this theorem states that the maximum power is delivered to a load when the load resistance is equal to the Thevenin's or Norton's equivalent resistance of the source. The efficiency trade-off is while this condition maximizes the power transfer, it also results in the source operating at only 50% efficiency, as the voltage across the load is equal to half of the source voltage. So coming to the applications, the maximum power transfer theorem is crucial in the design of power amplifiers, power transmission systems, and the other applications where efficient power transfer is important. So this is all about the maximum power transfer theorem. So next coming to the reciprocity theorem, voltage sources. The reciprocity theorem states that the voltage across a voltage source is independent of the polarity of the terminals. Coming to current sources, similarly, the current through a current source is independent of the polarity of the terminals. Resistors, the theorem also applies to resistors where the current voltage relationship is the same regardless of the direction of current flow. Coming to active devices, the reciprocity theorem has a limited application to active devices as their behavior often depends on the direction of current flow. So here the compensation theorem, principle of the compensation theorem is states that the effect of a voltage or current source in a circuit can be cancelled by the addition of a compensating source with the appropriate polarity and magnitude. So coming to applications, this theorem is useful in the design of feedback circuits where it can be used to eliminate the influence of a disturbance or error signal. So the limitations are the compensation theorem only applies to linear circuits and may not be applicable in the presence of non-linearities or active devices. So coming to the conclusion and applications of these theorems, uh, Thevenin's theorem simplify complex circuits to an equivalent two-terminal network. Now coming to the Norton's theorem, analyze the behavior of electronic devices and circuits. So the superposition theorem determine the overall response of a circuit with multiple sources. Maximum power transfer theorem design efficient power amplifiers and transmission systems. Reciprocity theorem understand the behavior of passive circuit elements. Coming to the compensation and the last compensation theorem. So coming to it, eliminate the influence of disturbances in feedback circuits. So this is all about the uh,